Hello everyone, welcome back to another GIS mathematics lecture video. And in this lecture video, I want to sort of go back through our two examples of calculating sine, cosine, tangent, and secant, cosecant, and cotangent. And I want to bring up a relationship or an identity that you may have already noticed, but we didn't explicitly talk about. And I want to take that nugget and build upon it to generate another set of relationships between these functions that can be really helpful. And so the first thing I want to do is I want to talk about this relationship between theta and phi in relation to this triangle here. So I'm going to hopefully not make this too messy. But again, what we have here is we have a 90-degree angle, right? This is the definition of a right triangle, is this 90-degree angle here. We also have theta and phi. So if we add in our theta and we add in our phi, right, the definition of a triangle is that all the angles sum up to 180 degrees. Hopefully this isn't new information to you. If it is, then just trust me here that this is one of the definitions of a triangle, is that the sum of the interior angles has to sum up to 180 degrees. So what this means is that because this 90 is always constant, right? This 90 is never going to change with our right triangle as we've defined them, right? This means that theta plus phi is going to equal 90 degrees, right? All I've done is taken this 90 off of both sides, right? So what we can do here is we can say that phi is going to be equal to 90 minus theta, and we can say that theta is going to be equal to 90 minus phi. All right, all I've done here is generated two different equations from this one here, isolating either phi or theta as what we're interested in. All right, so if we know theta, we can figure out phi, and if we know phi, we can figure out theta, right? That's what these two equations are showing. So you might be asking yourself, well, what does this have to do with the trigonometric functions that we've talked about so far? Well, hopefully you've noticed something interesting here, that the sine of theta is the same as the cosine of phi, and that the sine of phi is the same as the cosine of theta, and that the tangents are inverse of each other, right? The tangent of theta is the inverse of the tangent of phi. Right? And the reason this comes down to this reason right here, that these two angles are bound by this 90-degree rule. Right? So let's make that a little bit more formal here. Right? That the sine, I'm not going to bother with the e on the end, right? The sine of theta is equal to the cosine of phi. The sine of phi is equal to the cosine of theta, and that the tangent of, that's a terrible tangent, a terrible theta. Let's make that a little less sloppy. Right, that the tangent of theta is going to be equal to the inverse of the tangent of phi. Hopefully my phi's and my thetas aren't getting too close together. Hopefully you can tell them apart. But anyway, all right, so this is one set of relationships, and the same holds true for the cosecant, secant, and cotangent, right? But what we can do here is we can say that the cosine, right, since the cosine of theta equals the sine of phi, what we can also say is that the cosine, and phi is just 90 minus theta, right? We can say that the cosine of theta is going to be equal to, stick with our example here, that the sine of theta, right, is going to be the same as the cosine, right, of phi. but we said that phi is just 90 minus theta, right? So hopefully that makes sense. Hopefully I didn't take too much of a leap here. But we can relate sine and cosine based on this 90 minus whatever angle, right? So now we no longer care about phi, right? We've taken this relationship based on this table here, and we've removed the second angle from it entirely. And we're saying, given the sine of some angle, or given the cosine of some angle, right, we can figure out the other one, right? So let's do the same thing for cosine, right? Cosine of theta, right, we said was equal to the sine of phi. We can do the same thing again. We can say is equal to the sine of 90 minus theta, right? I'm just pulling in this equation right here, that phi is equal to 90 minus theta. I'm just replacing these up here with that. So hopefully that makes sense. And again, we can do the same thing down here. I'm going to pull it down just a little bit. Right, this is our example diagram for secant and cosecant, right? And we can see we have that same sort of trend here, right? That the secant of theta is the same as the cosecant of phi, right? The angles here have that same relationship of 90 minus, right? So what we can say here is I'm actually going to stop for just a second, breathe. I want you to sort of think about what we just set up before we move into the second set, right? Think about that idea of what it means when we say 90 minus phi or 90 minus theta, and what that means in terms of the secant, cosecant, sine, and cosine. Again, I encourage you to pause the video right now. If you're confused, go back and rewatch the first part before coming back here to go through the secant version, right? So let's go ahead and replicate what we talked about before, right? So we know that theta is equal to 90 minus phi, and we know that phi is equal to 90 minus theta, right? These are just the definitions of a triangle, of a right triangle as we've described it, right? And we also see here that the secant of theta is equal to the cosecant of phi. Right, so we can use this relationship again with this to say that the secant of theta is equal to the cosecant of 90 minus theta. And we can do the same thing with cosecant, right? We know that the cosecant of theta is equal to the secant of phi, right? That's this relationship right here. The cosecant of theta is the same as the secant of phi. So we can replace that with the idea that the secant, we can replace that idea with the cosecant of theta is equal to the secant, right? Again, replacing phi with 90 minus theta, right? That's what this equation is telling us that we can do, of 90 minus theta. All right. Hopefully this makes sense. What I want to spend the last couple seconds of this video doing, giving ourselves a little bit of space, is just remembering the fact that 90 degrees, right, this is in degrees, is the same as pi over 2 radians, right? We have this conversion metric from our angles video where we converted from degrees to radians and radians to degrees. And right, pi over 2 is the same as 90. So in degrees, right, those relationships hold, but they also hold true in radians. So if, for example, we have the sine of theta, and theta is in radians, right? That's the same as the cosine, right? We're not going to use 90 anymore because 90 was degrees. We would use pi over 2 minus theta, right? Same exact equation, nothing's changed here. We've just said that because we're dealing with radians, we're now using pi over 2 instead of 90. So hopefully this little addition here doesn't make you too confused. We're just showing that this equation works the same way for degrees that it does in radians. You just have to make sure that you're converting your constant here. So hopefully all this made sense. I know it's a lot. I strongly encourage you to go back, pause the video, rewatch any parts you're confused about, and as always, please reach out. Thank you.